All right, this was part 2 of Miss Levain's test. So first we have the givens. Let's mark them in the picture. AC congruent to BC, and we have CD bisects. All right, so we'll do that in a moment. We're going to get these angles are congruent by definition of an angle bisector. You can also write the definition out. Feel free to write an angle bisector splits an angle into 2 congruent angles. Splits an angle into 2 congruent angles. Then, oh, that was still given. All right, so let me just move that down a line. Definition of angle bisector. Then, of course, CD is congruent to itself. Now, look at the markings separate. Take one of these triangles out of the picture. Look at the marks. You can see now it's side angle side. I don't care if you write it like that or just side angle side. I'll accept either. The next question. Okay, so this is actually question number 17. All right, we're given angle 1 is congruent to angle 2, and then we're given AB is congruent to DE. And now we have the supplementary business. So angle 1 is supplementary to angle ABE. That's because linear pairs are supplementary. Same thing for angle 2 and angle DEB. Then we can say that these angles AB and DEB are congruent to one another because supplements of congruent angles are congruent. And then, of course, we have BE is congruent to BE. And then we have that these 2 triangles are congruent by side angle side. Again, it's easier to see if you take just one triangle out of the picture. And then you could see that the 2 triangles are congruent by side angle side. Okay, let's take a look at number 18. So this one, now you have to do it without any help. So we have C is the midpoint of BD. That's going to give us this. That's definition of a midpoint. You can also write a midpoint. You can write the definition out. A midpoint splits a segment into 2 congruent segments. Feel free to do that as well. Now we automatically have these vertical angles. This angle here and this angle here. Vertical angles are automatically congruent. Okay, these were both given. The perpendicular business gives us right angles. Okay, that's definition of perpendicular. Or you can write perpendicular lines form right angles. Now, pause for a moment. Make sure it's not hypotenuse leg. The hypotenuses are not involved. Here's the hypotenuses. They're not involved in the problem yet. So therefore, you want to state that these angles are congruent because all right angles are congruent. And then the 2 triangles are congruent by angle, side angle. Again, take one triangle out of the picture. This way, it's more obvious to you that it's angle, side angle. All right, let's take a look at number 9. So we have BAD is an isosceles triangle with the vertex at A. That means these are legs, kids. AC is a median, so that means these are going to be split, and we're going to have reflexive. So put the givens. Now I'm just doing this, but you have to write them out. Okay, number 2. I'm going to get reflexive out of the way. I'd like to get that done right away. Reflexive property. Then I'm going to do definition of a median next. BC is congruent to DC. Definition of a median. Or feel free to write a median splits a segment into 2 congruent segments. Okay, so then we have these legs congruent. So AB is congruent to AD because in an isosceles triangle, the legs are congruent. And now we can say that these 2 triangles are congruent by side, side, side. Most kids don't need to separate the picture for that. So if you need to, go ahead, but I'm not going to do that. Number 20. So we have MNRO. Then we have this MQPO. And we have this little piece congruent to this little piece, so we're going to end up using addition because we're going to need those holes. So first you put the givens. Then we're going to do QR is congruent to QR. Reflexive property. Then after that, we're going to use addition. PQ plus QR is congruent to NR plus QR, semicolon. PR is congruent to NQ. Addition property. And now the 2 triangles are congruent by side, side, side. A little tricky because you have the overlapping part, so you have to make a logical deduction. All right, so triangle POR is congruent to triangle QMN. All right, let's take a look at number 21. So we have AD, AF, that's these sides. And then we have AB, this little side, AC. And of course, we're going to have A is congruent to A. So this is a different reflexive. This one I definitely recommend that you separate the 2 pictures. So here's A, here's C, here's D. And they said that this side was congruent. I'll draw the other picture. All right, so then we have this triangle, ABF. So this is what we're going to have. Of course, you put the givens first. Then in line 2, we're going to put angle A is congruent to angle A. Reflexive property. And then the 2 triangles are congruent. ADC is congruent to triangle AFB by side angle side, because the angle is included. And then we just use CPCTC. CPCTC. Okay, the last one, if you recall, before I had sent you on your way, I had suggested that it was VY congruent to XY. Not a big deal. All right, now we're given this parallel stuff. Let me just see what we're told is parallel. I'm trying to get out of here a second so I can see. Okay, UV and WX. UV, WX. And these are also parallel. Eventually, we're going to do this proof a different way when we get to parallelograms. Okay, but for now, we're going to use the knowledge that you know. And VY is congruent to XY. Okay, Now, when you have parallel lines, as you know, you're going to be able to get alternate interior angles congruent. Notice I plan out the proof before I do it, okay? So you put the givens, which I certainly don't feel like writing those out. Okay, again, you have to. I already earned my right not to write it out because I've done it over and over again. You kids, however, have to write it out. All right, number 2. I'm going to call this angle 1 and 2 to take a shortcut. Angle 1 is congruent to angle 2 because when we have parallel lines, A, I, A are congruent. And then the 2 triangles are congruent. So triangle Okay, hold on one second. Oh, I looked at the wrong thing here. My bad. So I had written by mistake that these were congruent. I'm trying to prove those are congruent. Silly girl. All right. My Z is still intact. I need to do vertical angles here. I'm going to call them 3 and 4, though, to make my life easier. So angle 3 is congruent to angle 4. Three is congruent to angle 4, and that is because vertical angles are congruent. And then those 2 triangles will be congruent by angle, angle, side. You might want to separate it. Let me just draw one. One of the triangles by itself. This way it's evident. It's very helpful to do this. Okay, so triangle UVY is congruent to triangle WXY by angle, angle, side, because the side is not included between the 2 angles. And then VY is congruent to XY. And the reason for that is because of CPCTC. Now, a lot of times after this, we will ask you to prove that Y is the midpoint of VX. So I'm going to add that, okay? Y midpoint VX, and the reason would be definition of a midpoint. So that's how we can extend it. So just keep that in mind. I think that was the last question. All right, kids? So hope this helps. Thank you very much.